Hi guys, so yeah, we don't fit in the frame today. Not the video I had intended doing. We had some problems with that, so we're going to do another teardown. This is a large commercial NVR. It's quite an elderly analog one. Let me just peel it up. Oh, it's not light either. And show you the front. Bong. So as you can see, this thing is absolutely enormous. Lots of buttons, CD writer there, and then the back is even worse. How many connections do you need? There's a SCSI connection there for extra drives, and more connections than you can take a stick at. As you can hear, the lid is empty and off. Lid is empty, lid is open. I hope this isn't too dark. It's looking a bit dark. Just make sure it's not my phone. It isn't. Bear with. So this thing is just enormous. It is made by Dedicated Micros. This was made by Dedicated Micros. Have gone bankrupt. They're no longer with us. There are a lot of questions about how they handled themselves. This is a completely proprietary bit of kit, so no OnVIF stuff will work with this. None of the standard CMS will work with this. You plug it in to, I assume it will use anyone's cameras. Obviously analog BNC cameras, probably not AHD, and you are completely locked into their ecosystem, and they were still selling this very recently. One of the things that was brought up often with these is a lack of innovation. Depending on who you listen to, that isn't true. Basically they got a product that worked well, they stuck with it, they didn't evolve. So I'm just trying to see some dates on this because I don't know. Sorry, this is actually quite difficult to work with. Have we got a build date? No, we do not have a build date. Power supply maybe. Nope. Well, we've got a date on the hard drive. Or we should have a date on the hard drive. 2013 on the hard drive. I suspect the rest of this is quite a lot older. 2012 on the CD-ROM, so that is sealed in place. That's the original hard drives. So let's just get the obvious things out of this. Once we work out how you get the, you've got. But really. I don't believe that's the right way of doing this, but apparently you've got to put your screwdriver through the fan. That strikes me as less than ideal, so we're going to take the hard drive out. Notice that another sign of age on this is that this is a parallel ATA hard drive. User serviceability didn't really figure particularly high in the design of this, so we can't take the fans out. It looks like there are nuts on the hard drive brackets. Oh jeez, that's not coming out. Yeah, so it looks like there are nuts on the hard drive brackets, so you could probably spin those out and get them up, but I don't know that that would be any easier. Let's just, there we go, we've got that one there. And I can see that there is something on the back of the hard drive already, so that's another hint that we're older here than perhaps we could be. Older here than perhaps we should be. So we have, can I zoom you in on this? A fairly standard run-of-the-mill Western Digital SATA hard drive. Have we got capacity on here? 1 terabyte, so reasonably large disk for that particular time period. Let's bring you back out. And on the back of the disc we have a little board that converts this drive to SATA. To parallel IDE. It's been fairly well masticed on there. So I don't think we're going to be getting that one off. Oh, we really have gone utterly to town with the mastic on this. Let's just, excuse me there. Let me just see what we can do. Did that help? Oh. So it's quite obvious that you are not supposed to replace this. Let's just get in there. There we go. And we haven't quite got the last one. It's actually a silicon based adhesive rather than something like Sikaflex, and we have a IDE to SATA adapter. We have a date there that actually looks like it might be 2017. Let's just see if I can just catch this right on that Marvel chip. So that may mean nothing, but if that's going to focus for me, that to me looks like that could be a QC sticker from 2017. Which is obviously 4 years newer than the drive. That's not even an early SATA drive, so obviously we're using old stuff here. So what have we got here? So we have a label here telling us how to configure the drives. We've got IDE power connectors here. Let's just bring you in a bit and move you over. So we have IDE 0 power, IDE 1 power, IDE 2 power, fan 1 and 2, fan 3 and 4, keyboard, that's going up to the front panel, and LCD here. Let's carry on taking this. So let's zoom you out. So why glue everything on one end and not the other? And who knows? So your CD-ROM is IDE, and again, it's glued. That end is glued on the motherboard for some reason. And we have some kind of custom connector for the power supply there, and that is ATX 12 volts. That is a standard TFX, I think it is, power supply. So that will be staying, because that's almost certainly going to be useful, because those have an annoying habit of letting go. Let's just get this up on its end, get you to look at those connectors while I pop this out. Oh, that's just nasty. Okay, can I get this so you can see this? So there are standard pinouts, standard screw mounts for these power supplies, but what they've done is put one screw through there, possibly one through there, and then they've actually attached it using the fan. Obviously the fan's not designed to be a structural component. So I imagine if you drop this hard enough, you could probably actually smash the power supply out of it. Not that you should be dropping anything containing a hard drive anyway. That one's out. Get this back down. So we're mainly interested in this area now. So that is just a standard TFX power supply. So yeah, they've taken the screws that were in there from new, taken them out, placed it through the back panel, and then put the screws back in. I don't suppose there's anything really wrong with that. It just seems wrong. We'll put those back in there so they stay in there. We haven't got the CD-ROM. CD-ROM has got an adapter in the back, I can see that. I'll have to pause here and go get some tools. Right, back again. Anyone that knows me knows that I absolutely love this tool set. It's a fairly cheap set. It wasn't an expensive one, but it's great. It has pretty much everything you're going to need to do fairly major surgery in there. It's a Halford set. I think it's about £19. Over the years, things will get lost and misplaced, and about every 3 years I seem to buy a new one. You can't see me, I'm just dismantling the CD drive. And then I think what we'll do is we'll go for the front panel as well. There's another one in there we go. I'm interested to see what we're doing processor wise with the board. So that's a horrible noise. There we go. So CD-ROM, DVD-ROM, sorry. That's a fairly standard DVD recorder, and that's just got one of the usual laptop to IDE converters on the back. I don't know that it'll be SATA, it shouldn't be. But these convertibles can be useful. Yes, that is SATA. So we'll keep that together because there are still times where it's useful to have a internal DVD drive, and that's actually quite a nice one, assuming it works. Right, how does one take the front off? Well, there are screws. There are screws in the bottom and clips in the top. Well, we have something here that's quite obviously supposed to pull off. Same on the other side. Yep. Now you can't quite see me prizing this apart. So there are 2 screws there, 2 screws there. Let's wires them out. Oh, they were loose. Oh, I'm not expecting the front of this to be anything special. CCTV is one of the banes of my existence. We have a standard setup that we use on most sites called Blue Iris. Yeah, as I was saying, we have a standard system based on something called Blue Iris, which works really, really well. The trouble is it's not a cheap system and it's not suitable for all sites, and we use a lot of NVRs, and to be fair, the quality on them is highly variable. Even if you start going with big names like Hikvision, we've had problems with them, and I've got to go and deal with one tomorrow. That didn't feel great. And there's our front panel. We can't quite get that. Let's go back down. So we've got a ribbon. This is quite honestly absolutely vile, this machine. Let's get that ribbon out. There's our front panel. Do I put that away? I'm going to leave that out. So we've got a nice front panel board here. We have some test connections here marked PCLK VPP. So there's going to be some level of intelligence on this. So let's see what's going on behind this. After all, it is called a teardown, so we will tear everything down. I think that's all we've got. We're just hooked over on the top. There we go. bonus we're out. So everything there is moulded in. There is no sign of any provision for any form of display there. I didn't, to be honest, expect there to be. So that can go in pile. And what have we got here? This has slightly more intelligence than I thought it would. So we look to be using 1, 2, 3, 4, 5, 6. We're only using 6 of those 10 pins, so yes, there's obviously a degree of smarts going on here. We have various line drivers, and we have a PIC 16F747. So that is obviously talking back somehow. I would guess most likely serial. So that might be worth looking at. See if we can bend that to our will. So we'll put that aside. Right, I'm going to spin this round just because it's easier for me. And most of what we're interested in is this board, so let's zoom you in a bit. This is actually a lot darker than I expected. So what we're going to do now is release this top board and we'll have a look at that. And that's not quite the same bolt. I have a feeling we have to compromise on this because these aren't metric. So we have 4 serial ports here. Not overly sure what you would use them for, but they obviously do serve a purpose. If they're RS485, they could be used to control PTZs. A lot of the older analog PTZs use RS485, but we do have a dedicated 485 bus here. So we'll check that in a minute. And there are a lot of jack screws to undo here, and I can't believe it's going to be just the jack screws that hold it in. And as you can see, we've got some ribbons here rising off the board which will bring signals in. And we've got some fairly major chippery on here as well. So we'll have a look at that. This does appear to say that it is an I/O expansion. So what's this one? Auxiliary alarms. So that will be relay inputs, and auxiliary relays will be relay outputs. Bear with me a second. We'll just get... Oh no, I think we are just held in by the jack screws here. Let's pull that connector out. Look at the state of my hands just dealing with this, and we're out. So it looks like we've just got flexible ribbons, so we'll pop those off. Oh, they haven't glued them, but they are probably stiff from not having moved for quite some time. Oh, that one's just about come out, and the other one is over here. There we go. And we've got a power connector, I'm guessing, from there. So what have we got? We appear to have 2 common power connectors there, so I'm guessing we're daisy chaining that. There are more connectors down here, so it's possible you can add more of these boards. It looks like we're divided in between I/O and communications. We'll have a look, see what they say there. So we've got our read relays here. There'll be our alarm outputs. We have isolated and protected inputs here, which are probably being read by these. So this is all discrete logic. We have host bus and serial I/O expansion. So I'm almost certain this is going to be divided up somewhat along the lines of that. What have we got here? SP324, SP324, they're all fairly standard parts. LP, don't know what that is. LP621024DM. There appears to be a programming connector for it. That looks like an Intel chip. No, that's a microcontroller. That's a Hitachi H8 microcontroller. Then we've got our RS485 outputs, which are these, which have fuses on them, filters and everything. More read relays for that, which is auxiliary control outputs. Right, I think we're done with that board. Right, what do we do now? Do we see if we can get this board out? We've got some connectors on the back here which you can't see. And we've got an awful lot of crosshead screws, so we'll pull these all out. It's an interesting bit of construction compared to the other NVRs that I'm used to working with and other ones that I've seen. We did have a really nice Samsung one that came in, which we desperately wanted to put back in service, and basically it was just too old. But it wasn't built anything like this. I mean, certainly this is designed to be modular. This is the most you could put in this particular chassis, and my understanding is that this does all sorts of fancy split screen things and stuff like that that is actually quite difficult to do otherwise. However, how many channels am I seeing here? So there's 16 video channels marked A and B, not quite sure what that would be. Monitor A, which is an SVHS output, so you're not going to get high resolution over that. And then we've got audio output, so maybe you've got A and B, one is audio. I believe you can chain these up. Right, there is a SCSI connector there as well, which is handy, and that's something I wish that was more prevalent in modern NVRs, either a SCSI or eSATA. Just sometimes one hard drive is not enough. I mean, you are limited on the smaller units. I'll grab one out in a minute. And it would be nice to be able to chuck more drives in. Some do make allowance for 2. So that is a fast and wide. Is that fast and wide? It's SCSI 2 anyway. Right. Now what do we do? So I need to spin this again. There goes the gloves. Right, so we've got an expansion board here which adds 1, 2, 3, 4, 5, 6 channels, which seems like an odd number, but I think that's more a case restriction than a channel restriction. So let's pop that out. This is quite vile to work on. So there we go, more BNCs than you could shake a stick at. The glove's gone. Don't know that that's of any use to me at all. I do need to make some BNC patch panels for some radio stuff, but I don't think they'll be of any use at all. I'm talking UHF, so obviously there's no controlled impedance traces or anything on here. Shut that there. Right, let's see if we can get this board out. So our wonderful cables that we disconnected are actually ATX extension cables. They will be useful. So we've got fans here to disconnect. How do we take those off? Oh, we've got little clips on the side of those. They are microfits, I think. Oh, I've just nudged you again. Now, while I'm doing this, I am scanning the board to look for things that I recognise in terms of processor, and I'm not seeing anything. It's possible this is going to be completely Possible this might be completely FPGA driven, which seems strange, but there's no reason not to. It's just not what I'd expect. We'll have to clear that off another way. We've certainly got plenty of extra connectors on here for various things. It looks like we've got support for an internal SCSI driver as well. I don't know why you'd do that. We've got lots of IDE channels, so lots of hard drive space here. So this is obviously designed to go into multiple types of chassis. Can we get this out? No, because the fans are in the way. Chassis wise, that's it. There's really no use to that. I could take those fans out, but to be honest, they're going to be so old and knackered, there really is no point. Oh, Malamute has woken up. So we will just, certainly this is what happens for the old screws. So let's have a look at this board. So there's a couple of things on this that spring to mind. I'm not sure why I'm even bothering with that now. Take that one off. So yes, certainly this was designed for upgradability. This is camera 11 to 16 on this connector. Get rid of that. So we've got 3 IDE channels, which I'm going to guess is 2 drives per channel. So that's 6 hard drives plus potentially another 6 devices there. Obviously your CD-ROM drive is going to take 1. It's a nicely built module, and it looks like there is a lot of heavy lifting being taken away from various things. And we've got all sorts of chips. We've got RAM there. We've got 2 static RAM chips by the looks. That's flash. So there's not a lot of memory. We have a Xilinx chip there, Xilinx chip there, Xilinx chip there, Xilinx chip there. So there's a lot of custom memory, custom FPGA type goodness going on. There's one there. We have one of the ubiquitous and hated timekeepers. However, this is a later version of the Dallas clock chips. So with this version, you can actually change the battery. These yellow ones have started to pop up in equipment now, and you can just buy a new battery, or you can almost certainly sort those pinning out to do it yourself. We've got 128 meg disk on chip. This is almost certainly the operating system, and I believe that is soldered to the board, so we can't do much with that. We appear to have 5 decoder boards here. Now my understanding is that these are just that. It says VCD. Let's take them off. VCD something, covered by a label, which I am probably not going to be able to get off. Nope. Try. Oh, this one is going to come off. VCD-M it says, so video codec module I guess, and the other end one says something different, so apparently it's a different one. No, it just says super slot. If anyone knows what a super slot is, clean answers only please. So these are all identical as far as I can tell. Yes, 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 and yes. AO Holdings PLC, AO or AD? AD, they are the company, the holding company for the manufacturer of this, and I believe they hold some other stuff. We have some high-speed memory there. We have 2 Techwell chips. Not sure what those are. And a Burr Brown device there. Let's see. Yes, I know I'm using the wrong tool. If we can get that heatsink off and see what's underneath. Now that's a new one on me. There's a company I have never ever heard of. So the manufacturer, I don't know if you'll be able to see this if I zoom it right up. Tilt it around a bit. Maybe, maybe not. The manufacturer is a company called Chipright. They have a little boat as their logo, which means nothing to me. And I do not recognise anything on that at all. It's a really clever way of doing it though. I mean, it means you can mass produce these, and in theory you could possibly put extra functionality on these. I don't know if it would allow it, and it allows you to only populate what you need. So we've got 5 in there. We had 16 inputs. That doesn't really work. So I would assume that one may be used for something else, or they're possibly allocated as needed, or they've got a really odd combination of outputs or inputs. Who knows? There's going to be no documentation anywhere on these. Poking around the board then, we have our disk on chip module, Xilinx, 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 Xilinx and Xilinx. So that's all going to be discrete stuff. We have a Marvel chip there, paired with, not sure what that is. Looking at the connections, that could well be a SCSI controller. We've got analog devices. Let's change pointer. We've got an analog devices chip up there, which is going to be dealing with audio. SMSC chip there, which is doing LAN. Yep, that's networking there, and I suspect we've got networking activity lights there. This is going to be our processor, which we'll try and get to in a minute. RAM. And as I said, there is an awful lot of expansion that wasn't used. So we've got host bus expansion, which was the one that was going up to the top. That was marked host bus, I think, on there. VCO1 RS232 expansion, so that's more serial. Audio I/O expansion, so that's probably more audio ports. Certainly looking at the layout of this PCB here, it suggests there is a level of audio stuff going on. That might be a MUX in there. Regulator, there's your camera inputs, video expansion, again I suspect that's tied to this. JTAG and slot JTAG, so that's for this. So there's JTAG pins on these slots. So I think the only thing that we've really got left to do, TTL debug, that's going to be UART. We've got Firewire, positions for a Firewire connector there, which would be these up here. Not sure what that one would be. That looks like a DIN connector to me. Definitely looks like the pin out for a DIN connector of some kind. But I couldn't tell you what it was, it's just marked P33. To be fair, none of them are actually marked with their functions. So let's try and find out what processor is under here, if we can. That is an SH3. I believe originally a Hitachi design, similar to the SH4 that powers the Dreamcast. So not massively powerful bit of kit. Now the one last thing I wanted to do was to look for a date on this board, because I think these boards have probably sat around for quite some time before they've actually ever been used. So let's just clear a couple of these larger chips off and see if we can find anything resembling a date code. I think this was probably 10 years old when it was put together, which is interesting in terms of the speed that technology moves on. So yeah, maybe there is truth to the fact that some of this kit was quite old when it went out. Anyway, all done now, and hope you enjoyed.